Okay, so we've dealt with a number of topics so far today. Now we're going to end the day with a topic that's really simple, or maybe not. So we're going to talk a little bit about additives, nutrition, and health. And I want to introduce the moderator for this session, Dr. Hong Chan. And most of you know him already, but he was up until recently where is it? It was recently the National Program Leader for Bioprocess Engineering and Nanotechnology at the USDA, but he just recently retired and joined the retiree club. So, Hong, it's all yours. Thank you.
Thank you very much, Dr. Yan. And I was reminded by Joanne during this break that this is perhaps the most exciting session for this event. And so we'll see. Yeah. But nevertheless, recent discussion around the food supply and health have highlighted ingredients, additives, and contaminants. And we also heard it today, for instance, Dr. Lofterfield in her presentation mentioned about the importance of these, the ingredients, additives, and contaminants. So in this session, we will focus on three categories: low and no calorie sweeteners, interesterified oils, and packaging-related compounds. So first, let's welcome Dr. Tausif Khan. And Dr. Khan is a senior research associate at the Department of Nutrition Sciences, University of Toronto. And he will share his recent work using novel methods to synthesize observational evidence on sweeteners. Dr. Khan, the podium is yours.
Thank you. Thank you, Dr. Chen. And thanks for having me, inviting me here. I'm from Canada, as you know, I think it says, through Toronto. Weather is very nice here. It's 29 degrees. I just checked yesterday, it was 27. Really great. We have like freezing rain and less than 4 degrees in Toronto right now. I think Ottawa is even worse, as Will said. But thanks for having me for this session. And I research low-calorie sweeteners. So my topic today is low-calorie sweeteners, evidence for it, what do guidelines say, and any new directions that we can go or are going. Okay, I think I have to use this one. Yes, these are my disclosures. I think the things to note are I have written editorials and some papers regarding some of the guidelines, especially the WHO guidelines, what they say about low-calorie sweeteners. And I have some beef with them. And also, I'm a consumer of low-calorie sweeteners. So sugars have been a dominant public health concern for a very long time. And the dietary guidelines say that you should reduce intake of free or added sugars, which is what we should be doing. So WHO says less than 10% of energy daily intake should be from free sugars. Dietary guidelines for Americans, the new one actually says, I think it was mentioned before too, that no amount of added sugar is recommended, but then say that one meal less than 10 milligrams grams of sugars, added sugars. It should be less than 10 grams. Before that, it was, I think, 10%. Second, the UK guidelines less than 5%, Diabetes Canada and European guidelines is less than 5% or 10%. So generally, it's around 10% or less, but less than 5% of energy is, I think, recommended for even more health benefit. The question is, if you want to reduce sugar, what do you replace it with? And that's the question. Low-calorie sweeteners then becomes a tool where they can replace added sugars, especially in sweetness. And clinical practice guidelines universally, like we recently just did an exercise of guidelines and clinical practice guidelines. We went through around 23 of them, which we found, which mentioned low-calorie sweeteners, and all of them recommend using it for replacing sugars. These are all like diabetes guidelines, heart disease guidelines, obesity guidelines across the world. And only one guideline was saying that do not use it. That was IBD guideline, and they had no evidence. It was just precautionary. So clinical practice guidelines are very robust. So I'll just read out the American Diabetes Association, which says that low and no calorie sweeteners can be used instead of sugar sweetened products in moderation and for the short term to reduce overall calorie and carbohydrate intake. And American Heart Association says that for adults who are habitually consume SSBs or sugar sweetened beverages, low calorie sweetened beverages may be a useful replacement strategy. So that's, I think, the main thing, and every other guideline is similar. However, when we go to dietary guidelines, we also did a big exercise in this. Dietary guidelines are very conflicting. So we went through, I think, 72 dietary guidelines across the world. 36 actually mentioned low calorie sweeteners, and among them, only 30% actually recommended. The rest actually do not recommend it. So the previous dietary guidelines for Americans actually said that low calorie sweeteners may reduce calorie intake in the short term and aid in weight management, but now it has changed. If you see the bottom right, it says limit food and beverage that include low calorie sweeteners. And then UK and the European guidelines actually say that they can be a good replacement strategy. But WHO actually says non-nutritious sweeteners should not be used as means of achieving weight control or reducing risk of non-communicable diseases. Health Canada also says a similar thing, but and I'll show you why. I think there's some evidence why they present this and this. So the question is, why is there a disconnect between the clinical practice guidelines and the dietary guidelines? So I will just show you evidence of where we are right now, and then we go from there. So if you see, this is the evidence hierarchy, which I think many of you seen before, where so this is a pyramid. So as you go up, the risk of bias reduces and certainty of evidence increases, and also your inference towards causality increases, especially for randomized controlled trials. You can infer causality. Cohort studies is more difficult, and case control studies are below. And at the top of the hierarchy are systematic reviews and meta-analysis of RCTs, but also cohort studies can also be included, especially those which are done robustly. So this is a paper we published in 2022. One of our students, Nima McGlynn, she worked on this. So we actually asked the question, okay, so low calorie sweeteners actually, what are they used for? They're not used in isolation. They're used to replace added sugar. So we said, okay, what about all the trials which looked at sugar sweetened beverages, replacing them with low calorie sweetened beverages, and then also put water in there so we can see. And then we did a network meta-analysis. We can compare all three to each other. And the intended substitution, when we looked at intended substitution where low calorie sweetened beverages replace sugar sweetened beverages, we see a benefit for body weight, BMI, body fat, and liver fat. So all the green ones. And the certain evidence was moderate mostly and some low. If we look at sugar sweetened beverages replaced with water, now, we don't see any benefit here, but that's what's happening is the effect estimates actually point in the right direction. It's just the issue of power. We don't have enough studies. If you look at a number of studies, they're very few, but they're pointing in the same direction. And then a reference substitution. Okay, so if you have water and you replace it with low calorie sweetener, you can do that. We see some green, a red, and a green. But actually, what's happening is these are trials. So there was a benefit in both arms. So for example, in body weight, look at HbA1c, for example. There was a benefit in both low calorie sweeteners arm and the water arm. But there was a more benefit in the water arm, so that's why it shows red. So same with body weight and same with systolic blood pressure. So actually, there's no harm. And when you compare them against each other, you see increase or decrease, but actually, it was benefit for both. Then this chart actually shows all the recent meta-analysis on RCTs. The Rios-Levras one is the WHO commissioned one, which is one of the largest one, McDinn, Awarth, and Rogers, and others. And when the issue is the nature of comparator matters. So when low-calorie sweeteners displace sugars, when you compare it to sugars, which actually give calories, and then you see a benefit in body weight, which is expected because sugars have calories, they increase body weight. Low-calorie sweeteners do not have calories, so that's understandable. If you compare it to water, you see no effect, and that's what we should be seeing. Against water, they have no calories, they have no effect. With energy intake, we have a similar response. So low-calorie sweeteners actually displace calories. They do not have their own effects. And I'll go into detail a bit more later on this. However, when we look at cohort studies, that's where the problem arises. So I'll just show you this big, massive, I think they looked at more than 100 cohort studies. This is a WHO commissioned systematic review meta-analysis of prospective cohort studies, and they show evidence of increased association with obesity, type 2 diabetes, CHD, stroke, CVD mortality, total mortality with low-calorie sweeteners. And this is where they took their evidence from. And if you look at just naively at this association, these analyses show harm. So how do we reconcile this? What happens is, why are we seeing this signal and not the RCTs? So what happens is, especially what they do is they use these kind of studies use a prevalent or baseline analysis, which are prone to reverse causality. So high-risk individuals adopt low-calorie sweeteners as a risk reduction strategy. Then there is a residual confounding where the people are different, which cannot be controlled, and behavioral clustering because there are other health conscious effects going on with those people who are taking low-calorie sweeteners. But I'll just explain it a bit more. Imagine somebody is taking as a sugar sweetened beverage or as a very high intake of added sugars all their life. Okay, that person, although that population or that group will gain weight, will be at high risk of heart disease or obesity, and a downstream risk of other chronic diseases. Now these people actually switch to low-calorie sweeteners or low-calorie sweetened beverages. And when we do a prevalent analysis, we capture that. When we look at their usual intake, we look at their intake at the start of the cohort study and then the disease pattern. And the usual intake actually say they're taking low-calorie sweeteners, but actually all their life for the rest, the previous 20, 30, 40 years, they were taking high intake of sugar. So that is not being captured. So in a sense, the low-calorie sweetener is actually capturing their previous high intake of sugars. So you can't eat, so the signal actually is not of a low-calorie sweetener, the signal is of high intake of sugar. And this is very well known. So a lot of papers, editorials, commentaries, some written by our group, and guideline expert consensus is they all agree that reverse causality, because this then causes reverse causality, meaning that the risk of disease actually drives the association rather than the low-calorie sweeteners. So this is well known that in this field, reverse causality is a major issue, and we need to tackle this. WHO, when they gave their recommendation, they actually gave more weight to the cohort studies, which had very low certainty, and less weight to the RCTs. But they did acknowledge that the reverse causality is an issue, but they did not address it. And also similarly, I'll come to dietary guidelines for Americans. So I looked at their data. What they did was, they didn't do a novel original analysis. What they did was umbrella meta-analysis. So umbrella meta-analysis, you take the latest meta-analysis and put them together and then show the results. So this is umbrella meta-analysis, which just shows these low-calorie sweeteners are associated with type 2 diabetes, mortality, CVD, obesity, and Alzheimer's. Obesity, I think it's this, not significant, but anyways. So then they say, okay, limit food and beverages that include local sweeteners, and no amount of non-nutritious sweeteners is recommended. And it's 19 meta-analysis they looked at, and RCTs they actually ignored. So they actually say, and it's in the red on the right, existing RCTs are relatively short, small to moderate size, and limited to metabolic effects rather than hard clinical outcomes. So we are looking at hard clinical outcomes, so they don't matter. So the majority of evidence was from non-randomized trial. They say that. However, in the end, they say potential for confounding due to healthy adherent bias and reverse causation is there. So the question is, then how do you reconcile the beneficial effects on biomarkers you see in RCTs compared to cohort studies? And WHO did the same thing. They ignored the RCTs and just say, okay, RCTs has show benefit, but we'll focus on the hard outcomes. And DGA actually then says that we have a research gap here. Observational study, we have limited ability to establish causal relationship, and we need more robust longitudinal cohort studies to strengthen the evidence base. Can we do that? Yes. So this is my main work here. So we can do, so cohort studies, there was a prevalent analysis where issue of causality is a major issue in this field. However, what you can do is a substitution and change analysis, which controls for reverse causality. And what we did one, so substitution analysis is what is the intended substitution? So in a sense, the question is not if local sweeteners are harmful per se, but how they're used. They're used to substitute sugars. So you have to look at that question. So we did the same analysis we did for trials, we did for cohort studies, picked up all the cohorts which had this analysis, and I'll go one by one. So this is a substitution analysis of cohort studies. So this is a systematic review and meta-analysis of cohort studies which looked at substitution of sugar-sweetened beverages with locally sweetened beverages. And if you look at this, the green means that they're showing a benefit of replacing or displacing SSBs. And all the effect estimates are either beneficial or neutral for all the major hard outcomes, if you can see here. Similarly, and then SSBs with water, we see a benefit too, so that's understandable. We should get that. And when you compare as a reference substitution, water versus NSBs, there's no difference. They're actually no different from each other. The interesting thing is these studies were available when WHO did their analysis, but they did not look at those. What we also did was we compared our results with WHO results. So these are the prevalent versus the robust methods, which is the substitution analysis and change analysis. So these red ones are, for example, obesity, type 2 diabetes, CHD, stroke, CVD, and total mortality. WHO shows harm, the red ones. And when you look at our robust analysis, either the harm disappears or there's a benefit. There's not a single outcome where we see harm when you use robust methods for all these major cardiometabolic hard outcomes. So WHO, I said, did not consider these robust methods, which is very strange because they have a precedent for this. So in 2015, they had a paper looking at saturated fat, CVD, mortality, and type 2 diabetes. They actually did not find an association. And actually in those, in the discussion, it actually says the dietary guidelines for saturated fat must carefully consider the effect of replacement of nutrients. So it is not, the question is not, are they harmful per se? The question is, what do they replace? What do they displace? Like whenever you take food, you have to displace something else. So that's the major question. And 2022, they did another analysis where they look at replacements, and then they show convincing evidence that saturated fatty acids should be replaced with PUFA and MUFA and slowly digested carbs. So they did this in that one, but not in the locally sweetener one. There is one more question I want to address here is some people say, okay, local sweeteners do not have an effect, but maybe they affect your appetite hormones or gut hormones, or the sweet taste uncouples from calories, and then you have to eat more, or you have craving for food, leading to metabolic disruption, dysregulated glucose, insulin, GLP-1, and so these effects are actually not proven, but there's a lot of papers which actually try to provide this kind of I think mechanism. So what we did was we looked at all human studies where acute metabolic hormones were looked at for local sweeteners given alone as a preload, meaning that before meals, so 15 minutes before meal, and then with meals. So we looked at all of those, and then did a network meta-analysis for all these outcome: glucose, insulin, GLP-1, GIP, ghrelin, glucagon, and none of them showed an effect. So just give you an example. So this is a league table where individual NNS blends compared to caloric sweeteners and water. The major effects were seen only with caloric sweeteners and not with local sweeteners. So actually, they do not have any effect on gut hormones. Regarding the paper that was discussed for the food classification principles, I was thinking of local sweeteners, and I think the major issue is like I think some of these guiding principles apply here. Biological link is not there for local sweeteners and a risk. It just doesn't exist. Causal evidence, if you use robust methods for cohort studies, then it aligns with RCT evidence, which actually you can say it actually strengthens the causal evidence for them being beneficial when they replace added sugars or excess amount of sugars. And scientific bodies are, interestingly, the clinical practice guidelines actually follow GRADE very religiously, but I think dietary guidelines do not. So then they have these conflicts. And finally, this is a mega. We know that robust methods are important. So we have started this mega cohorts pooling project. We're taking mega cohorts, like cohorts with more than 100,000 people and 1.6 million participants. So these are all the cohorts we have getting data from, trying to include in this big analysis where we want to look at robust methods. And we did a preliminary analysis using published data. So these are the cohort study with published data. We looked at substitution with the sugar-sweetened beverages, and we see similar results to our previous paper. We see a benefit, not a single signal for harm. And more to come soon. So we'll be publishing this one first, and then we are planning to do an IPD analysis in the coming years. So in conclusion, RCT show that local sweeteners displace excess calories from sugars, leading to weight loss and cardiometabolic improvements similar to water. Prospective cohort studies using robust methods, meaning substitution and change analysis, are consistent with trial evidence. They reduce type 2 diabetes, CHD, and mortality risk. There's no evidence of metabolic disruption from low and no calorie sweeteners in mechanistic studies in humans. In animal studies, you can get a lot of things because they give supraphysiological doses, but humans are different. Guideline disconnects are driven by reliance on bias-prone prevalent analysis. So majority, if you focus on just the usual cohort studies, which are prevalent analysis, you will see a signal for harm, and that's actually not, it is prone to bias due to reverse causality. And mega cohorts project will strengthen, hopefully in the future, strengthen causal inferences about the robust methods that we are using. Thank you for all, and thanks for having me.
Very much, Dr. Khan. We might have a question just for one quick question. Yeah.
Thank you for the presentation, Dr. Khan. My name is Kirsty Canine-Adams with Ingredion. One of my concerns is we're making conclusions when the evidence, the great evidence, is often low to very low, and we're making broad statements about LNCS when really these are a diverse range of compounds. Are we confusing the public when we make such statements? And how do we do a better job communicating to our public health officials and to the public about the nuance of all of this LNCS science?
Yeah, I think these are just 2 points, are very important. I think you're right. Cohort studies start as low in grade hierarchy. They start as low and trials start as high. They can be upgraded due to, for example, dose response, others, but usually you don't get it. So they remain as low or very low. That's a problem. But majority of dietary guidelines is based upon cohort studies, especially, and then there is we just cannot have that level of confidence. We just have to be better and explaining that to the public. Also, the problem with cohort studies is that they look at FFQ data mainly, and you cannot separate individual local sweeteners. So we can study them as a group, but we cannot separate them. For them, to separate them, you have to look at trials. But trials, for example, with the sweetened beverages, they're also usually not individual, but they're actually a mixture. Especially the dietary studies. Only in acute studies, which I showed, you can have separation. So that's a major issue. They have individual effects in how they are metabolized and excreted. However, overall, together as a group, we can give, I think, conclusions based upon the results that we see in the RCTs and the cohort studies.
No. We're getting off time.
Yeah.
And let's be very clear. Normally, I don't care except that there's alcohol in a short little bit. So thank you to see if I know you're going to be around. We can ask you some more questions. Handa, please go ahead and introduce our next speaker.
Very good. Thank you very much. I appreciate that. So thank you, Dr. Khan. Our next presenter is Dr. Faridon Shahidi, who is joining us virtually. Dr. Shahidi is a university research professor in the Department of Biochemistry at Memorial University of Newfoundland. He's internationally recognized for his basic and applied research on food lipids and phenolic antioxidants. So we welcome here today to share insights on interstate oils in food. So Dr. Shahidi.
Thank you very much, Dr. Chen, for your kind introduction. And I would like also to thank the organizers for making it possible for me to join you virtually. So I'm told that I have to have some disclosures with respect to what I have here. And I have really no conflict of interest. I have served as expert witness in some court cases in the United States, but they have been mainly in the topics related to lipids, but unrelated to what I'm talking about today. And I was sent a form that I also filled it, and you can see that my grants mainly have been from NSERC, Natural Sciences and Engineering Research Council of Canada, and I've been editor-in-chief of several journals, and where I have spoken, it's been basically non-stipendiary. Has been just having my travel cost covered, and I have no share in any companies or others, and my employee is the university, and I'm supervising just the graduate students and postdoctoral fellows. With that, I move on to basically recognize lipids and fats and oils as a condensed source of energy, which we all know. And in addition to providing essential fatty acids and fat-soluble vitamins, they are very important in texture of the food and obviously for the flavor of it. And if we don't take care of it, it produces off flavors. With respect to the texture, the mouthfeel and lubricity is very important that one needs to consider. If we look at a triglyceride or triacylglycerol, which is the correct name for it, we have the glycerol molecule, and we have three different groups, fatty acids attached to it. If they are in the terminal parts, we call them substitution number 1 and 3, SN1 and SN3. And if it is in the middle, it is SN2. And you can see that if we have double bonds, these double bonds are all cis or Z configuration, and they give a curvature to the fatty acids, so they are not just linear as such. And this is very important when we are looking at enzymatic reactions. Now, if we want to modify fats and oils, there are different ways. We can mix a couple of different lipid sources together, or we can fractionate them. If we consider, for example, palm oil, we can change it and fractionate it to palmolene and palm stearine. And if we want to harden the fat or partially still keep it liquid but less sensitive to oxidation, we do hydrogenation reactions. But if we want to keep some of those properties without going through hydrogenation, we may do interesterification. Obviously, genetic manipulation is something that is also at disposal. Now, if we just look at this slide, I have taken it from a publication, is not my own. I have to declare that, but these are in public domain. If we use a catalyst, we can basically interchange all these fatty acids. So if we have a stearic acid, oleic acid, or linoleic acid, these could be interchanged depending on the enzyme or the chemicals that we may use. And having said that, I can basically define better interesterification, which is basically changing the fatty acids in different positions in a triacylglycerol molecule or tag molecule. And this is bringing about a lot of changes in the physiochemical properties of it. And we can do this either enzymatically or chemically. And this is, again, something that is very important in the production of what we call a structured lipid. We can structure them the way we want with the properties that are desirable to us. Now, in this slide, I don't know why it doesn't show here. Do you see it or you don't? Okay, it showed it. If we use SN13 specific lipase, we can, such as using pancreatic lipase, we can have products that are very different depending on what we want to do, interesterification, alcoholysis, or acidolysis. So the position 2, SN2, remains intact, but position 1 and 3, SN1 and SN3, changes. Now, this is showing enzymatic one using 1,3 specific lipase. And you can see again here that if we have 2-triacylglycerol, the R2 and R5 remain intact, but the other ones can interchange. I haven't shown all possibilities. There are more possibilities that is not necessary to show. And if we do it non-specifically or chemically, we can change everything. We can scramble all of them, including position 2. So we get a whole soup or cocktail of the fatty acids that are very different in their properties compared to the original material we have had. Now, why do we want to use structured lipids or modified lipids with interesterification, for example? Well, we want to have targeted lipid metabolism. We may want to change their bioavailability, and we may want to have better health impacts. And obviously, it is important in terms of oxidative stability. So if we are having a triacylglycerol that is highly unsaturated, and we go and put saturated fatty acids in it, then we are able to make it more stable. But there is a pitfall there that I'm going to explain it also. So overall, we use these structured lipids for use in infant formulas, human milk fat substitute, instead of having hydrogenation in margarine and shortening preparation, cocoa butter substitutes, low-calorie products, and enteral and pre-enteral nutrition. So there are having different effects and properties. Now, the simple interesterification could be compared with the blending of the fatty acids that we have, blending of two oils together. It gives us really no molecular changes, but it doesn't really serve any improvement in functional properties. While with interesterification, we may be able to deliver that kind of changes that would be necessary. Now, in human milk fat substitute, here we know that in the human milk, palmitic acid is in the SN2 position. And if we want to have human milk fat substitute, we can change that with different fatty acids, like oleic acid. And here we change this. If we have all of these as palmitic acid, and palmitic acid gets released, that will form calcium salt, and therefore it has problems for the babies for constipation and other effects that may not be desirable. Now, with the human milk fat substitute prepared this way, we may have enhanced absorption, and they may have also effects on better bone mineralization, brain development, and gut health, amongst others. And obviously, the nutritional equivalency is something that would be something we want to achieve in these kind of properties and effects. Here, one can use different enzymes to achieve this. For example, single cell oil, Arasco, arachidonic acid single cell oil, together with medium chain fatty acids, and we can put C8 and C10 into the molecule. And here, C8 and C10, they are readily absorbable for energy use and so on and so forth. And it is something that we can consider. One can use the same kind of reaction using palm stearine and fish oil. And again, the enzymes that are used gives us structured lipids where we can have EPA and DHA in the molecule. Or we can have amaranth oil with Dahasco, DHA single cell oil. And these are very important, that we can have different products. So there are challenges, and also there may be things to consider for future development. The important thing is that we have to recognize that sometimes when we do this enzymatic reaction, there may be a migration of the acyl group, even when we use the 1,3 enzymes that are specific, 1,3 specific enzymes. And this is a point that I may be making later on, is that if that happens, it will bring, and this is one of the problems that has been raised, may make those interesterified oils similar to animal fat, and therefore maybe at high level be hypercholesterolemic. In terms of the other properties, obviously we have enhanced properties and functionality. Obviously, in terms of this way, we may have problem for scale up because the enzymes we are using, unless we are able to recover them, it will be in the product stream, and we have to neutralize them. And we may require approval for that. Now, with respect to the hydrogenation, interesterification provides us the benefit because when we do hydrogenation with nickel catalyst, whether it is selective or non-selective, it produces up to 50% trans fatty acids. Remember, we were told by nutritionists, our good friends, that stop having animal fat, stop having butter is not good for you, go to margarine. Well, we were told later, we were wrong. This gives you trans fatty acids, which is 4 times more deleterious to your health in terms of what can happen. So we are taking a step back, and we have a better understanding of the situation at this stage. With respect to the enhanced nutrition structured lipid or interesterified oil, they are good in terms of having potentially important fatty acids put into the molecule to be more similar to the mother's fat if it is for infant, but if we are using it in food for margarine and shortening, again, that is important. It gives us also the texture and sensory properties. It has a good mouthfeel. Imagine you have a piece of pastry and you bite into it and liquid oil comes out from 2 sides of your mouth. It is not really very nice, and it doesn't have the sensory effects that you want. And we can have this with extending the shelf life of the product. But again, here I emphasize, and I later may get into it, that we may need to have natural antioxidant added to the molecules. Because one thing, I haven't gone over my slides, I just put them together. I may point out, during interesterification, we are able to get rid of a lot of natural antioxidants. Those are the tocopherols, because we release a lot of these fatty acids, and they can esterify the tocopherol. And once you esterify tocopherol, it's no longer antioxidant. And we found this the hard way when we were doing some reactions, putting saturated fatty acids in highly unsaturated oils, and we found the stability was still declining, which is very different from expectation. So this is something we've got to be very careful about. Now, this is one of the challenges that I have it on this slide. And the oxidative stability has to be something that we look at it very carefully in terms of what we are using in margarine and shortening, and unless we use them within a short period of time, and even if it is for other usages. So one has to look at all these possibilities that may exist. Now, the other one is cocoa butter substitute or cocoa butter equivalent. As you see, these days, cocoa is becoming more and more expensive. We see that. We do the same for the coffee. Suddenly, depending on the production areas, if it goes down, prices start going up. And we need to have a seamless integration of the blends to have this produced. And we can have natural sources to make this possible. Obviously, cocoa butter equivalents, the price is a lot lower compared to the cocoa butter. But again, this is something that we have to see how we are going to go about it with fractionation, enzymatic modification, and the rest of it is not just the cost, but is also other properties, how we can well mimic the crystallization pattern and properties of it. And for this, we can use different source of oils and fats: palm oil, illip fat, mango kernel fat, cocoa fat, sal fat, and shea butter, whatever you can pronounce it. So again, here we can see different publications that show how the modification can take place and how we go about that. I'm trying to watch my time also not to go over. Here, obviously, something that you see again, the fatty acids are very different and depends on how we would like to have it. Medium chain fatty acids are quite important for their quick release and absorption, readily to give energy. And this is also good for those who have health implications and problem. In terms of some of the commercial product and calorie reduced lipid, we have some examples given here, because the calorie reduced lipids generally give us about 5 kilocalories, 5 calories per gram instead of the 9 kilocalories that we are having. And this is very important of what we are using. Caprenin is one of them. Behanin is another one. Stractol lipid is another one. And Milcopas, yet another one. And these are the ones that are very much used either for having low calorie cocoa butter substitute, milk fat mimic, and prenatal nutrition, human milk, and again, human milk. Now, here is another one giving you some of the same ones, but some different, and the companies where they produce these ones. I haven't worked with any of them, so I'm clear from having any conflict. I'm not promoting them, I'm just mentioning these are the producers. There are other applications. We may have to use them for having, putting together certain oils that could be used not only for nutritional support, but also used in cosmetic products. And this is, again, where the money is when you get into the cosmetic ones and how well you can do it. In terms of the delivery system, we can have plastic fats that are having versatile applications. And obviously in pharmaceutical area, there are interest in this kind of lipids. Now, in Canada, we have the Bunge producing a triacylglycerol that makes use of structured lipid or interesterification, and it's received regulatory approval only last year. And it has different fatty acids, and its use is mainly in baked good, baking mixes, beverages and beverage bases, and dairy analogs, amongst others. Now, labeling requirement, obviously, it is something that is, since November 2025 in Canada, is not mandatory. And in that, it is recommended that they say, for example, this has interesterified soybean oil. But again, CFIA, Canadian Food Inspection Agency, encourages labeling, but not strictly requiring it. So I went suddenly into something that I didn't intend to go. So let me get out of this. But if you want to read more about it, you can go and get that information from there. In the US, there has been really not too much regulation, but depends on which state you are in. In Texas, as of January 1, 2027, they say labels must indicate the use of interesterified oil in the formulation and the content. So it is very important. In Europe, you still don't need it. King's College of London looked at possibility of effects on heart health, and this is something that is not what I know about because it's not my area. I don't do any human or animal studies, but they found in reasonable amount it didn't raise cholesterol level and didn't cause metabolic harm to healthy adults. So that's what was said there. And generally, I mentioned earlier that they say some of these interesterified oils, once they are consumed, during the production of the interesterified oil, there may be migration of the fatty acids, and this may lead to products that are similar to animal fat, and therefore they may increase LDL cholesterol. But Inform, in March 2026 issue, this is a publication from American Oil Chemists Society, said that taken all together, recent findings in human using commercial interesterified fats consumed at realistic amounts consistently suggest these oils have no adverse effect on the lipid and glucose metabolism and cardiovascular diseases. So there are some research gaps that one could look into, long-term human studies, to find out really what is happening and whether these distribution and redistribution of the fatty acids has any effect, particularly with respect to the positional distribution. And oxidative stability of these is always very important. I mentioned that even when we put saturated fatty acids into these oils, they were not more stable, and we had to add additional antioxidant to make them stable. On the digestive system, these are still not well understood what it may be happening, and regulatory labeling is something that it should be harmonized so that we don't have every place a different kind of regulations. So in summary, making tailored nutritional profile with interesterification processes, these have their own benefit and their own drawbacks in terms of the safety. I think robust clinical studies remain to be done. And obviously, with respect to versatility of the health application and impact, it is something that we have to look in the path forward to realize the full potential of interesterified structured lipids, and interdisciplinary collaboration from food technologists, clinical nutritionists, and regulatory agencies needs to be done, and then proceeding to right labeling, transparent labeling practices, and evidence-based, not just the type of evidence that is sensational and not true to reality. So we have to be responsible to bring in cutting-edge food technology where it meets rigorous clinical validation and transparent consumer communication. With that, I thank you for your attention.
Thank you very much, Dr. Shahidi. We're running over time, and let's see if there's one burning question. I see none. So thank you very much again, Dr. Shahidi. So
all right, thank you very much for sharing this talk, and I appreciate, and I hope that it was of some benefit to the listeners. Thank you.
Absolutely. This is really excellent and very informative. Thank you very much.
You're welcome.
Yeah. Our next presenter is Dr. Andrea Dearline. Yes. Yeah. Dr. Dearline is the Director of Public Health and Nutrition and Associate Professor of Public Health and Nutrition at the New York University School of Global Public Health. She was a member of the 2025 and 2030 Dietary Guideline Advisory Committee. Now the podium is yours.
Yeah. Great. Thank you. So I got up here quickly. All right. So last talk. So here are my disclosures for everybody. Okay. So, and I'll be talking about basically chemicals in our different basically food packaging. So we'll see. So in a recent series of So in a recent series of The Lancet, they reviewed the evidence on the increasing consumption of ultra-processed foods and its association with the development of chronic diseases. Okay, got it now. All right, perfect. And so one of the plausible mechanisms that they gave sort of to at least partially explain this association between ultra-processed foods and chronic disease is that there's an increased intake of toxic compounds. And so specifically, they highlighted PFAS, BPA, as well as DEHP, BBP, and DBP, which are all phthalates. Okay. So just as a quick outline, I'll be talking about sort of chemical exposures in our diet. I'll specifically be reviewing these chemicals that they highlighted. I'll talk a little bit about human health impact as well as biomonitoring data. So there are numerous ways, obviously, that we can be exposed to chemicals in our environment. So we can inhale them through air and dust. We can absorb them through our skin by using various personal care products and hair care products. We can be exposed to them through our interactions with the healthcare system. So thinking about using medical devices, medical equipment, as well as even taking certain medications. We can ingest them through dust. And this is particularly problematic when you think about infants and young children who are closer to the ground and have more hand-to-mouth contact. And lastly, we can obviously ingest them through our diets. So diet is a major source of our chemical exposures, and chemicals can get into our foods into three main ways. So we've heard about sort of thinking about chemicals that are being intentionally added to our foods to have some sort of technical effects. So thinking about emulsifiers or preservatives. They can also get into our foods through environmental contamination. So they're present in our foods. They're present in our foods because they're found in the soil, water, or air where our foods are grown, raised, or processed. And then lastly, what I'm sort of touching on more today is thinking about how they may enter our food through food packaging materials, as well as processing equipment. So thinking about conveyor belts or plastic tubing. They can be on food preparations surfaces, as well as in cookware. And so BPA, phthalates, and phosphates, or PFAS, are chemicals that are used in plastics and other food packaging materials. And so they're really being used to add sort of flexibility and durability, as well as potentially helping with resistance to water and grease and oils. And so these properties are used to really help with maintaining the food's shelf life, protecting the foods or the food contents from, biological or chemical changes. They can help with, transporting our foods or temporarily storing them, as well as with food preparation. So you can think about how, we buy a lot of foods that are maybe in containers where they're meant to be either reheated in them, or think about things like boil in a bag or throwing the bag in the microwave. So cooking our foods within their packages. And so different examples of these, you could think of like plastic wraps, lining of metal cans, plastic bottles, plastic jars, lids, as well as adhesives. And so the other thing I just want to note very quickly about dietary exposure to these chemicals is that it's a particular concern because it does have the potential to reach all ages, as well as all life stages, and especially groups that may be vulnerable to these chemicals at lower exposure levels. So thinking about infants and young children, people who might be breastfeeding or lactating, as well as those that might have specific health conditions. So starting off with bisphenols. So bisphenols are synthetic phenolic compounds that are used primarily to produce polycarbonate plastics, which are strong and highly durable plastics. They can also be used in epoxy resins. These are applied to coatings on metal surfaces, so thinking about metal cans. And they're also used in the coating of thermal paper. So think about what's commonly coated in receipt paper or maybe tickets. So BPA, bisphenol A, is probably the one that we're all most familiar with. It is one of the highest volume global chemicals, but there are other bisphenols that are used in different types of packaging and food products that you can see listed there. And additionally, there are also replacement chemicals, right? So as these chemicals, there's more attention to them, either research attention plus public pressure, you often see that there are chemicals that are going to be used that have similar structures as their replacements. So there's BPS and BPF, which you are likely being used in products that are being marketed as BPA free. So although bisphenols have short half-lives, so normally they're very quickly metabolized and excreted from our bodies with acute exposure. The main issue with these is that we think of them as sort of being ubiquitous in our environment. And so having chronic daily exposure is potentially of concern because then they're sort of, persistent in our body. So in terms of food, diet is going to be, the primary source of human exposure to bisphenols. So bisphenols enter our food by primarily migrating from the epoxy resin linings of both food and beverage cans. They can also migrate from polycarbonate plastic containers, so thinking about water bottles or plastic food containers. And then additionally, approximately 30% of thermal papers are included in our recycling stream. So these chemicals can be detected in recycled paper and cardboard food packaging. Migration of these chemicals is going to be impacted by certain factors. So obviously thinking about a longer storage time. So the longer time that the food's in contact with the packaging, they're more likely to leach. Heat and damage to the container. So you've probably heard the advice of sort of if you're using plastic containers that look like they're cloudy or they're scratched up to throw them out, because it's more likely that the chemicals can leach out into the food. Similarly, like with dishwashers, don't put the plastic in the dishwasher. And then lastly, it's going to depend on the food actually being packaged. So foods with higher acidity, as well as foods with higher fat content, often seem to have higher levels of these chemicals leaching into them. So in studies that have looked at foods and looked at concentrations of these chemicals in foods, what they normally see is that when you look at a packaged food, it's going to have higher levels of these chemicals compared to their unpackaged counterparts. So you can see the range, cereals, meat, fish, spices, beverages. It's also important to note that with some of these foods like fish may be getting it from, polluted, that these chemicals are in the, polluting the waterways or oceans. Additionally, with things like meats and dairy, they also may be getting it through more of the processing that's going on, as they're being prepared for consumption. And then in studies that have looked at, human exposure. So now we're trying to get at understanding how much people are being exposed to them. What we'll normally do is look at, okay, what are people reporting as their intakes, and then look at metabolites. For example, with bisphenols, would be looking at metabolites in their urine. And so what we see in those studies is that individuals who report higher intakes of foods, canned foods, so thinking about, soups, pastas, and vegetables, that they had higher levels of exposure to these chemicals compared to those who reported eating fewer canned foods. Additionally, there was a study actually looking at the healthy eating index, and they showed that individuals with lower healthy eating index scores actually had higher levels of exposure to BPA compared to those with higher healthy eating index scores. So next, phthalates. So phthalates are a large group of chemicals. They're used as plasticizers. So they're making the plastics more flexible and durable. Phthalates are also used as solvents, adhesives, and fragrance stabilizers. And so they're used in a wide range of products. So they can be found in vinyl flooring, shower curtains, medical tubing and devices, cosmetics, and a huge range of personal care products. So our exposure to phthalates mostly comes from ingestion through diet, as well as personal care product use. So there are several phthalates that have been linked to dietary exposure, so the ones that were highlighted in the Lancet article, but there are others that are also used in food packaging materials. And as I mentioned, similar to, BPA, there are phthalate replacement chemicals. So DEHP tends to be the phthalate that's gotten a lot of attention. And so there are replacement chemicals that are currently in use for replacing DEHP in these products. And similar to BPA, phthalates also, or bisphenols, phthalates also tend to have short half-lives. So they are being sort of rapidly metabolized and excreted. However, our concern is more with, this persistent exposure. So in terms of phthalates coming from food, plastic food packaging made from polyvinyl chloride, including cling wrap for fatty foods, plastic containers, adhesive seals, and coatings, as well as processing equipment. So thinking about, plastic tubing and plastic storage containers tend to be where we're getting our exposure from. Similar to bisphenols, there seems to be greater migration of phthalates into our foods with higher fat content of those foods. In studies that have looked at concentrations within food sources, we tend to see that there's higher concentrations of phthalates in foods like poultry, oils and fats, and dairy cream, while foods that consistently have sort of lower detectable levels of phthalates tend to be yogurt, milk, jarred fruits and vegetables. When studies have looked at people's intakes of foods and their phthalate exposure, what we see is that people who consume higher amounts of foods from away from home, so thinking about cafeterias, restaurants, fast food establishments, have higher exposure to phthalates compared to those people who are reporting consuming more foods at home. And then lastly, PFAS. So PFAS are a very large, complex group of synthetic chemicals that are used globally in a very wide range of products because they are strong surfactants. So they're able to repel water, grease, stains. So they're used in nonstick cookware, water repellent clothing, stain-resistant fabrics, as well as firefighting foams. So due to the chemical structure of phthalates, they are sort of long chains of both carbon and fluorine atoms. PFAS do not easily degrade in our environment. So some of them have biological half-lives up to 15 years. So they have been nicknamed forever chemicals. So they persist in our environment. They're contaminating our soil, water, and air. They can bioaccumulate in humans and animals, as well as biomagnify through the food chain. And so due to their growing sort of persistence in our environment, and concern about this, there have been phasing out of these chemicals in the US beginning in the early 2000s. But again, there are replacements. So there are short and ultra short chain PFAS, which are definitely more rapidly eliminated. But at the same time, there is still some health concerns about them. And actually beginning in 2020, some of these shorter chain PFAS have begun to be phased out. So we look at PFAS in foods. Dietary exposure to PFAS, the main route is contaminated drinking water, as well as some of these contaminated foods. You can think of like fish, shellfish, animals coming from the more environmental contamination. However, they can be found both in food processing equipment as well as packaging. So they're going to be added to paper products to hold liquid or hot or greasy foods. So we see the concern has been around, fast food wrappers, pizza boxes, as well as microwave popcorn bags. And so again, it's in studies looking at human exposure, they found similar that people who are consuming more foods away from home had higher exposure to PFAS, and they especially saw this in people who are consuming a lot of popcorn as well as restaurant foods. So how do these chemicals impact our health? So these chemicals are all considered endocrine disrupting chemicals. So the endocrine system, which we might be aware of, is sort of coordinates the hormones that regulate, all different processes throughout our body. The endocrine glands are distributed throughout our body and produce hormones that, target cells related to nearly all of our body processes. So thinking about metabolism, reproduction, growth. And so endocrine disrupting chemicals have the ability to directly interfere with these natural hormones that we have in many different ways. So they can interfere with their production, release, binding, transportation, elimination, et cetera. And so unsurprisingly, then you can imagine that there is a huge amount of literature looking at these endocrine disrupting chemicals with various adverse health outcomes. So you can see on the slide, they've been attached to poor birth outcomes, particularly preterm birth, neurodevelopmental outcomes, issues with immune response, reproductive health issues in both males and females, a range of cardiometabolic conditions. So thinking about like weight gain, liver damage, type 2 diabetes, as well as certain cancers. And so due to this, as you can imagine, there's been efforts to reduce human exposure to BPA, phthalates, and PFAS, particularly from food sources. So in Europe, most of these phthalates that had been highlighted in that Lancet infographic are really heavily restricted or banned from use. And in recent years, the FDA has, strengthened a lot of the regulations around food contact materials. So there have been the removal or highly restricted use of phthalates in food packaging materials. BPA is still allowed in food contact material. However, industry has already really shifted to the replacement. So when you see it's not really being used anymore. Similarly with PFAS, there has been a phase out of those chemicals as grease-proofing agents in packaging. So, as I mentioned, due to sort of this increasing regulation as well as public pressure, these chemicals are being replaced with other chemicals in many of our consumer products. So, there is human biomonitoring data. And so that really allows us to have determination of the internal circulating levels and excreted concentrations of chemicals. However, it should be noted that they account for exposures from all possible sources. So in the United States, human chemical exposures have been monitored by the CDC using the National Health and Nutrition Examination surveys. And so they collect blood and urine samples from participants. And this really is used to provide a big picture view on chemical exposures in the US population and to identify, trends of individual chemical levels by, certain population groups. And so recent examination of temporal trends in NHANES really shows that there's been decreases in some of these chemicals that, again, were highlighted in that infographic, but we are also seeing increases in other chemicals. So substitution. So there have been substitution of, DEHP and some of the more problematic phthalates with other types of phthalates, as well as also seeing increases in these substitution or these replacement chemicals. So this is just showing for urinary concentrations of BPA in these populations. You can see that these have been decreasing. Similarly, for BBP, DEHP, and DBP, we've seen over time that these are still detected, but have been decreasing. And then similarly for blood concentrations of PFAS, particularly after the ban, you see that exposure levels have also been decreasing. So I just wanted to make a quick note about some of these replacement chemicals as well. So when we look at human exposure to some of these chemicals, studies have shown that, BPF and BPS are pretty prevalent in human biospecimens. So 88%, 74%. DEHP replacements, as I said, DIDP and DINP are phthalates that are being used instead of DEHP, and we've seen them, increasing in NHANES analyses, as well as some of these alternative chemicals. And then even with the PFAS replacements, so these short and ultra short chain replacements, there have been studies that are look at sort of within the home environment, are these being detected? And yes, both in, dust and water samples, as well as being detected in human serum. So this is it. So, the last slide, last of the day. So, this is more sort of limitations. So, assessing chemical exposures, particularly from food packaging, is really challenging. So as I've mentioned, these really are found in a wide range of our products and what we're exposed to, which makes it really difficult to isolate exposure from these specific sources. Regulatory safety limits are usually set for individual chemicals, but the truth is, that if you look in the literature, we really expanded to looking at mixtures because we're not really just exposed to one chemical or exposed to maybe this is depressing, but we're exposed to a lot, on a daily basis, a lot of different ones. Testing for chemicals, as you can imagine, both in foods and in humans is pretty expensive, and really difficult for large scale efforts, particularly for trying to look at chemicals in foods. A lot of the studies do note that even when looking at identical foods or batches of the same products, you'll often see variations in the levels. Oops. And yeah, so they often vary. And as I mentioned, there's a lot with the chemical migration from the different products, depending on these numerous factors, right? That can affect the leaching out of the chemicals into the foods. And then lastly, it's great that there are these shifts in trying to find replacement chemicals to be used in products. But at the same time, a lot of times they do have similar chemical structures and potentially may have the same effects as the chemicals that they're replacing. So you can imagine, though, that this is really difficult, though, to keep on top of this if we're trying to look at both biomonitoring programs, so thinking about having the correct assays or tests to be able to detect these things, as well as think about research on health outcomes and how that's going to really lag behind when we're already being exposed to them. So that's it. So, thank you.
Thank you very much, Dr. Dillon. And we allow one question, just one quick question.
So really appreciated the presentation, and this concern about replacement chemicals is a big one. But I've got a comment about the framing that I feel I have to, and maybe Neil Saab has a similar thought, but the way you kicked it off saying chemicals can be found in food, we've got such a huge educational thing going on at the moment to help people understand that food's made up of chemicals. And I think the framing around chemical contaminants helps to clarify it, or unwanted chemicals. But it's just, I think the more people talk about chemicals in food being bad, it doesn't help this consumer piece. So we don't want them to be scared of chemicals. The food's made up of chemicals, but contaminants or unwanted residues or contact. Yeah.
Yes, I guess that would be a pretty thing, especially in the environmental epi group of people, switching from endocrine disrupting chemicals, maybe endocrine disrupting toxins, or right? Something like that.
Yeah, chemical contaminants is a usual term, but or unwanted chemicals or whatever. But I just think it's really important because a lot of the public in particular is interested in these forever chemicals and stuff, and the framing for them to help them not get over worried and get a better understanding about the makeup of food, I think is helpful. But I just felt I need to point that out, but I really appreciate the presentation. Thank you. Yeah.
Martin, since you called on me,
Yeah.
I'm jumped in. So thanks for that comment. We often talk about NIAS, non-intentionally added substances, to distinguish between intentional and unintentional. But my question for you is, how does this tie into processing? Because those chemical categories that you listed, PFAS among others, they can be present in packaging of fresh fruits, fresh meats, as well as processed foods. What does this tie into this?
So I did not tie it back into a process of that exact point, that these things are, these are more in the packaging, right? So, or the containers that you might use at home. And so you might buy something fresh or a piece of beef and put it in a plastic container. So I was trying to really I thought it was, they're really found in a wide range of products, and food packaging or food is not the only way that we're exposed to them. So yes, I think, and I didn't highlight, maybe I should have, but these chemicals get very confusing. There was like an Ennies analysis where they looked at ultra processed food intakes and phthalates and BPA. And what they found was there was nothing with BPA. There's no difference by ultra processed foods. And then they found the other two phthalates, but not DHP and not the other one. So it was a little bit, with what the Lancet had sort of highlighted as being these main sort of targeted chemicals or substances of concern that it's a lot. It's a lot. So yeah, I agree that maybe some of it is that we have to have some messaging maybe around packaging, but I also understand that like we have to pack their food and transport them, store them, and.
Can I make one quick comment, Tongda?
Stop him.
Yeah,
Stop.
so,
Stop.
some of us may know that FDA through NHANES and USDA through FSIS have been serving PFAS quite extensively in the foods they regulate. And I think they're determining like less than 1% of the samples have PFAS. The ones that do are extremely low levels. So and they tend to be fish commonly coming from Asia. So that really the PFAS in the foods that we buy and consume are really quite low.
Yeah, I mean, that was my, like, that was the whole. I was trying to make the point that they're really everywhere. Look, when I studied phthalates were mainly, we talk all about personal care products, that anything that has a fragrance in it has a low molecular weight, so, yeah, I totally agree.
Well, thank you very much. We thank all the three excellent speakers, and I see I'm over in 5 minutes, so let me turn it over to Dr. Yen.
Thank you for that great session. And so this brings us to the end of today's regular scheduled program.